Hello guys, welcome back to our channel. Today in this video we are going to see a major topic from fluid mechanics, that is loss in pipe flow. Here we are going to study loss in pipe flow and a problem regarding it. So let's move on. Losses in pipe flow. When a fluid is flowing through the pipe, it experiences some resistance due to which sum of energy of fluid is lost, that is loss in pipe flow. Mainly loss in pipe flow are of two. First one is major loss and the second one is minor loss. Major loss is due to frictional resistance of pipe which depends on inside roughness of the pipe, and the minor loss mainly due to pipe fittings, change in flow direction and change in flow area. First one, major losses. Head loss due to friction in pipe can be found out by using, first one is Darcy's Weisbach equation. This Darcy's Weisbach equation used for both viscous and turbulent flow, and it can be found out by using the equation HF is equal to 4F dash L V square by 2GD. HF denotes the head loss due to friction in pipe. F dash, it is coefficient of friction, or it's also called Mann's friction factor. L gives the length of pipe and V is the mean velocity of flow, and D is the diameter of pipe, and in which F dash can be found out by using the formula 16 by Reynolds number for Reynolds number less than 2000, that is it's a laminar flow, and F dash is equal to 0.079 by Reynolds number raised to 1 by 4 if Reynolds number varies from 4000 to 10 to the power 6, that is the flow is turbulent. We also see another equation, that is HF is equal to FL square by 2GD. Here F is equal to 4F dash. F dash is coefficient of friction and F is called friction factor or Darcy's friction factor. And F is found out by using the equation 64 by RE. Next one is Chassis formula. Head loss due to friction in pipe can also be found out using Chassis formula, and it is given by V is equal to C root Mi, where C is Chassis constant and M gives the hydraulic mean depth or hydraulic radius, and I is head loss per unit length. And hydraulic mean depth M is found out by using area of flow by wetted perimeter, that is D by 4 in case of pipe. And head loss per unit length is given as I is equal to HF by L. So on rewriting the formula, we get V is equal to C root D by 4 into HF by L. From that we can find out the value of head loss, and this Chassis formula is mainly used to find out the head loss in open channel flows. And the head loss due to friction in pipe can be obtained using Chassis formula once we know the value of velocity and the value of Chassis constant, that is C. Next one is Hagen-Poiseuille formula. When the flow through the pipe is viscous, then we can use the formula Hagen-Poiseuille for finding out the head loss through pipe, and it is given by HF is equal to 32 mu VL by rho GD square, where mu is the viscosity and V is the average velocity, rho gives the density, then next L is length of the pipe, G is acceleration due to gravity, and D is diameter of pipe. So when the flow through the pipe is viscous, then we can use the formula Hagen-Poiseuille for finding out head loss. The next one is minor loss. Minor loss due to many reasons. First of all, minor loss due to sudden expansion. Head loss due to sudden expansion. Here we can, in this figure we can see initially the pipe diameter is D1 and suddenly increases to D2, and velocity also changes. Initially velocity is V1 and the final velocity is V2. So head loss is found out by using the formula HL head loss is equal to V1 minus V2 the whole square by 2G. Then next one is head loss due to sudden contraction. Here diameter of pipe is suddenly decreases and thereby flow also reduce. Here head loss is given by the equation HL is equal to V square by 2G into 1 by Cc minus 1 the whole square, where Cc is not given, then HL is equal to 0.5 V2 square by 2G, and Cc is coefficient of contraction. One is the loss of head due to an obstruction in pipe. If there is any obstruction in pipe, it causes loss of energy, and there is sudden enlargement of area of flow beyond the obstruction, and due to which loss of head takes place. And loss of head due to obstruction is given by V square by 2G into A by Cc into A minus 1 the whole square, in which V shows the velocity of liquid in pipe, small a is the maximum area of obstruction, and capital A is the area of pipe, and Cc is the coefficient of contraction. Due to obstruction in pipe, it causes loss of energy, and there is sudden enlargement of area of flow beyond the obstruction, and due to which head loss takes place. And loss of head due to obstruction is found out using the formula V square by 2G into area of pipe upon coefficient of contraction into area of pipe minus area of obstruction minus 1 the whole square. Next one is a problem. A pipe 0.5 meter dia taking off from a reservoir suddenly expands to 0.3 meter at the end of 16 meter and continues for another 15 meter. If the head above the inlet of the pipe is 4.88 meter, the actual velocity at the exit, taking into consider all the losses, and assume F is equal to 0.044 the complete pipeline. Here figure shows, according to the question, a pipe 0.15 meter dia having a velocity V1, and it suddenly expands to a pipe of diameter 0.3 meter, and its velocity is V2, and it's also given length of pipe V1 is 16 meter and the length of pipe of dia 0.3 is 15 meter, and it's also given head above the inlet of the pipe is 4.88 meter. Then we have to find out the actual velocity at the exit by considering all the losses, and also given F is equal to 0.04. Firstly, we have to write what all things given in the question, and after that considering two sections 1 and 2, and applying Bernoulli's equation, we can write P1 by rho g plus V1 square by 2G plus Z1 is equal to P2 by rho g plus V2 square by 2G plus Z2 plus losses. And in this, P1 and P2 get cancelled since it's in same line, and V1 square is also 0, and Z1 is given as 4.88, that is already given in the question. Then V2 square, that we have to find out V2 square by 2G plus losses. Then we have to consider what all losses coming in this problem. First one is major losses, considering major head loss in pipe 1 and pipe 2. Let it be HF1 and HF2. HF1 be the major loss at pipe 1 and HF2 will be the major loss at pipe 2. Then we are considering minor losses. Minor losses at the entrance of pipe. We can see the minor losses at the entrance of pipe, and due to sudden expansion of pipe from diameter changes from 0.15 to 0.3. Mainly two major losses. One is at the entrance of pipe, that is from reservoir to the pipe, and then is sudden expansion of pipe. Equation will be 4.88 is equal to V2 square by 2G plus losses. Losses includes HF1 major loss in pipe 1 plus HF2 major loss in pipe 2 plus HL entrance, that is head loss at the entrance of pipe, and HL expansion, that is head loss due to sudden expansion. Then we have to apply continuity equation, and continuity equation is given as A1 V1 is equal to A2 V2. A1 is area of pipe 1, V1 velocity at the pipe 1, then similarly A2 area of pipe 2, and V2 is the velocity of flow through the pipe V2, and A1 is given by pi by 4 D1 square into V1 is equal to A2 is pi by 4 D2 square into V2, and on solving we get V1 is equal to D2 by D1 the whole square into V2, and by giving the values of D2 as 0.3 and D1 as 0.1 meter, we can, on solving we get V1 is equal to 4 V2. So we have to substitute value of V1 as 4 V2. Then find out the each losses. Firstly HF1. HF1 is found out using the formula FLV square by 2GD. Here value of F is already given as 0.04. On substituting the values of F as 0.04, L1 is given 16 in terms of V1. V1 is right in the terms of V2. Then V1 is equal to 4 V2, and D1 is also given. On solving we get HF1 is equal to 68.27 V2 square by 2G. We are going to find out the value of HF2 major loss in pipe 2, and it is given by FL2 V2 square by 2G D2. Here also all values we know. Just substituting we get HF2 as 2 V2 square by 2G. Then we have to find out HL, head loss at the entrance of pipe, and it is found out using the formula HL is equal to 0.5 V1 square by 2G. 0.5 into V1 as 4 V2 by 2G. On substituting we get 8 V2 square by 2G, and finally we have to find out head loss due to sudden expansion, that is find out using the formula V1 minus V2 the whole square by 2G. On substituting the value of V1 as 4 V2, we can get HL due to sudden expansion is 9 V2 square by 2G. In all the values of losses in equation 2, then we get 4.88 is equal to V2 square by 2G plus 68.27 V2 square by 2G plus 2 V2 square by 2G plus 8 V2 square by 2G plus 9 V2 square by 2G. In all terms V2 square by 2G is common. By taking V2 square by 2G outside, then we get 1 plus 68.27 plus 2 plus 8 plus 9. On solving we get 4.88 is equal to 88.27 V2 square by 2G. On solving we get V2 square is equal to 1.085 and V2 is equal to 1.039 meter per second. Hope you all understood this question. Thanks for watching.